In today's lab, we're exploring conservation of energy. So we know that energy cannot be created or destroyed. It can only be converted from one form into another form. And there are lots of types of energy, but for this experiment, we're just looking at kinetic energy and potential energy. So kinetic energy, that's the energy of motion, the energy that an object has because it is moving. So if an object has mass m and velocity v, then its kinetic energy is 1/2 times its mass times its velocity squared. Potential energy is just stored energy. And for this experiment, we're looking at gravitational potential energy, which is the potential energy that an object has due to its position within a gravitational field. So the formula for that is mass times gravity times its height above some reference point. So if I wanted to find the potential energy of this ball relative to my hand, then it's going to be its mass times gravity times its height above my hand. Right now, it's got 0 because it's sitting on my hand. Its height is 0. But if I move it up to here, then the potential energy is going to be its mass times gravity times the height above my hand. So as long as there are no non-conservative forces, throughout an entire process, the total mechanical energy should be conserved. So a non-conservative force would be something like friction or drag, something that removes energy from the system and converts it into some non-useful form like heat or sound. So as long as we don't have anything like that, the total mechanical energy should be conserved. So if I toss this ball up in the air, I give it an initial kinetic energy when I throw it, and then it converts it into potential energy at the top, and then it converts it back into kinetic energy when it gets right before it gets to my hand. And as long as there's no non-conservative forces, then the total energy should stay the same. So if you add the kinetic energy and the potential energy at every point in time along that process, then the total energy stays the same. And that's the sort of process that we're looking at in this experiment. So the experiment is going to be very simple. We're just going to take a ball, toss it in front of the camera, and record its motion, and then we'll track it later on the computer. So the first thing that we need to do is weigh the ball. We need to measure its mass. So for that, just grab your spring balance and your ball and some duct tape. So just tear off a small piece of duct tape like this, and then you're going to tape the ball to the spring balance hook. Make sure that you've zeroed the spring balance. I've already done that with mine. So just take the ball and tape it to the spring balance hook. You don't want to use very much duct tape. If you do that, then that will add some mass to the ball. But just hang it like that. We showed you how to do this in some of the previous videos. So just check the mass like that and record that. And you'll want that in kilograms. So make sure to record that. Then we need to set up the camera. So I've already got this set up here on a chair. So I've got a chair set up, and then I put a book on here. The chair was kind of soft on top, so I didn't want the camera tipping over. So this provides a nice firm surface. And then I'm going to use the wood block and rubber bands again to make a phone stand. So I'll just take the rubber bands and stretch them around the wood block. So I just stretch one of them and then do 2 of them just to keep it extra stable. And then I'll connect my phone, I'll slide my phone in there behind the rubber bands. So for this experiment, you will want the phone in the vertical orientation most likely. So I'm just going to set it up like that. And then you're going to face the camera towards the wall. And you want to set it up so that it's facing directly at the wall. You want a light colored wall because the ball is dark colored, so we want it to show up against the wall. And then we need it about 2 meters away from the wall, depending on your lens. We want it to be far enough away that we can see a good portion of the ball's path like that. Then what we want to do is set up our tape measure. This will be used for calibration later. So just set the length to 1 meter, and then set that on the floor in front of the camera. So then you're going to want to check and make sure that you can see both ends of the tape measure in the view of the camera. Okay, so that looks good. We can see both ends of the tape measure, and we can see the wall. Now we also want to make sure that we can see a vertical line and a horizontal line. So I'm just going to check for that real quick. And right now we can see that it's not visible. So what I want to do is just reposition the camera just slightly. Still want it facing directly at the wall, but now we can see the edge of this and the bottom edge of that. So That will be useful when we align our X and Y axes on the computer. So now all we need to do is start the camera recording, and then I'm going to toss the ball from this side, and it's going to create an arc across and then land somewhere over here. So it needs to start somewhere close to the tape measure and then land somewhere over on this side close to the tape measure, and the peak needs to be somewhere in the middle so that we get the full parabolic arc across the view of the camera. If you have a hard floor though, you could bounce it. Like I could go over here and then just bounce it off the floor so that it bounces an arc or something like that. That would be totally fine as well. Just make sure that you use the portion while it's in the air. Okay, so I'm going to go ahead and start the camera.
Just a quick reminder here, if you're using an iPhone or an iPad to film your experiment, then you need to go to the Settings app and scroll down to Camera, and under Camera go to Formats and make sure that you've selected Most Compatible. If you use the high efficiency format, then the program tracker will not be able to use your video files. It won't be able to open them. So just make sure you select Most Compatible and you should be good.
So this will probably take several takes, but just be patient, do it several times until you get the right one. And then later you can go back and trim your video to a shorter clip and then just use that one segment that actually worked. So that one was actually pretty good. It had the peak somewhere in the middle, and then it started and stopped somewhere within view of the camera. So that would be maybe an ideal run. I'm going to try it several more times though. So most of those were actually pretty good. Some of them may not have been as good as I thought they were. You just have to go back and look at the video later to see if they were actually good enough. But you're just going to keep trying it, and hopefully you'll get some that work, and then you'll trim your video shorter, use that for your analysis, and that's it. So as always, make sure to read your instructions carefully. They've got more information than what's in this video, so read through that, and good luck on your experiment.